Hi everyone, it's Mrs. Summer here to talk about lesson 602, what is a mole and Avogadros number? So the goals of this lesson is to define a mole, relate a mole to everyday things, and relate a mole to Avogadros number. So if you remember, in Unit 5, gas laws, we used the idea of a mole. We said a mole is a way to measure how much gas there was. In this lesson, we're going to learn more about what a mole really means in the context of chemistry. It's true, it's a way to measure how much gas there was, but there's more to it than that. So what exactly is a mole? A mole is a counting unit in chemistry. So like a dozen is 12 of something, a mole is 6.02 times 10 to the 23rd of something. So that's 6.02 with 23 zeros. For example, a dozen grapefruits is 12 grapefruits. A mole of grapefruits is 6.02 times 10 to the 23rd grapefruits. So to compare this to something you know, 1 dozen eggs equals 12 eggs, which 12 eggs weighs approximately 52 grams. 1 mole of water is 6.02 times 10 to the 23rd water molecules. Remember, atoms is just an individual element. We refer to as molecules when it's a chemical compound. And 8.02 times, so 1 mole of water is 18.02 grams of water. So if we were in school, I would have brought the Legos out. We would have been doing this really fun activity. I'm sad that we're not. But 1 Lego car equals 4 wheels. Okay, so to make a Lego car, you need 4 wheels. But these wheels here are 3 grams of wheels. If you weigh them out, there might be 3 grams. What if you change the size of the wheels? You still need 4 wheels to make a car, but they might weigh different. Also here, 1 mole of NaCl, so table salt, is 6.02 times 10 to the 23rd sodium chloride molecules, which is equal to, let me change this. It is not equal to that. It is equal to, so that is actually equal to 58.43 grams of sodium chloride. So 1 mole of sodium chloride is 6.02 times 10 to the 23rd sodium chloride molecules, and it has a mass of 58.43 grams. So why moles? So we have to think about, when we're asking why do we use moles, we have to ask, how does the reaction occur? They occur on a molecule to molecule or atom to atom basis. This is the microscopic scale. We cannot count the number of atoms or molecules one by one. This is why we balance our equations to start with. So the same number of atoms we end up with as we started. So the conservation of matter. So we look here, if we have CH4 plus 2O2, when they rearrange to be CO2 and water, we have the same number of molecules. That's how we counted when we were balancing chemical equations. So how can we measure a substance? So we use mass or volume to measure how much of something we have. These are the macroscopic measurements. We can see them, we can handle them, and we have tools designed to measure them. We don't have a tool designed to measure a mole. There are no balances to measure a mole. There's no graduated cylinders to measure a mole. So we need something macroscopic that we can relate it to. So we can't count the number of atoms using tweezers, like picking them out. We can't, they're too small. Mass and number of molecules, atoms needed to have a relationship to help convert between the macroscopic and the microscopic world. The mole allows us to make this conversion. We can use the mole, so putting the mole here, and we have grams over here, and we have molecules or atoms over here, and the mass and we can use the mole, Avogadros number, and mass to determine how much of the reactant we need and how much product we need to make in a chemical reaction. So in the real world, so when are you going to need this? Mole conversions and grams and to moles and balanced chemical equations you'll be using if you go into the medical field, any type of sciences, engineering, even in like cosmetology and hair coloring and all that kind of stuff. you use this concept almost daily. You may not use moles to atoms or atoms to moles in the real world. Nobody's going to really ask you how many atoms are there, but understanding the foundation of it and what it really means will help you make the real world connections between all the other units. So, how big is Avogadro's number? It is so big that it is sometimes incomprehensible to understand how large it is. So, the distance to the moon is 238.9 thousand miles. So in scientific notation, it's that. The expanded number is 238,900 miles. So the distance to Mars is 84.034 million miles. And if you look at the scientific notation, that expanded number is 84,034,000 miles. The number of seconds in a year is 31.54 million. And that looks like that as an expanded number. Years Earth has been around is 5.54 billion. So your scientific notation is 5.54 times 10 to the 9th. And the expanded number looks like that. So the population of the Earth is 7.8 billion. So that's 7.8 times 10 to the 9th. And that looks like that as an expanded number. The U.S. national debt, 27 trillion. That's 2.7 times 10 to the 13th. That looks like that expanded. Seconds the Earth has been around is 174 quadrillion, which is 1.747094 times 10 to the 17th. That number looks like that. Avogadro's number is the number of particles in 1 mole of something. So remember before we talked about 1 mole of water is 18.02 grams of water. In that, there are 602 sextillion particles. That's 6.02 times 10 to the 23rd. And if we look at that, it looks like that expanded. That number is so large that there's nothing else we can relate to it to help our understanding of what it means. So this video, I want you to watch. It's going to be attached to this the 602C assignment in Google Classroom. I can't play it on Edpuzzle due to copyright issues, so I'm going to post it. It's really entertaining, and it has really great graphics for you to kind of understand how much is a mole, of how big is Avogadro's number.